Welcome back to the Cisco NetAcad CCNA Switching, Routing and Wireless Essentials lecture series. If you haven't seen my previous lectures, I will leave a link in the description for the playlist. I would also recommend that you watch the Introduction to Networks lecture series before you move forward with this series. Today, I will cover module number 7, which is DHCP version 4. The primary objective of this module is to learn how we can implement a DHCP version 4 to operate across multiple VLANs. We will cover DHCP4 concepts, configure a Cisco IOS DHCP4 server, and configure a DHCP4 client. DHCP version 4 concepts. Dynamic Host Configuration Protocol version 4, also known as DHCPv4, assigns IPv4 addresses and other network configuration information dynamically. Because desktop clients typically make up the bulk of the network nodes, DHCP version 4 is an extremely useful and time-saving tool for network administrators. So by having a DHCP version 4 server, you don't have to go to all of those desktop end devices and configure IP addresses. It will be automatically obtained from the DHCP server. A dedicated DHCP version 4 server is scalable and relatively easy to manage. However, in a small branch or small office, home office type location, a Cisco router can be configured to provide DHCP version 4 services without the need for a dedicated server. Cisco iOS software supports an optional, full-featured DHCP version 4 server. The DHCP version 4 server dynamically assigns or leases an IPv4 address from a pool of addresses for a limited period of time chosen by the server or until the client no longer needs the address. Clients lease the information from the server for an administratively defined period. Administrators configure DHCP version 4 servers to set the leases to time out at different intervals. The lease is typically anywhere from 24 hours to a week or more. When the lease expires, the client must ask for another address, although the client is typically reassigned the same address by the server. One of the key things that you should get out of this slide is that the Cisco switch software, the Cisco iOS, do come with fully featured DHCPv4 server, and the DHCP version 4 server is not a big application. The DHCP servers are not big application even in version 6 that would hinder the operation of your devices such as routers and switches. So you can have a DHCP version 4 server or even version 6 server, which we will cover in our next topics, on a small device such as a router or a switch, and it shouldn't have an impact. However, you obviously can have a dedicated DHCP server if you want that option implemented in a large scale business, for example. So let's look at DHCPv4 operation. DHCPv4 works in a client server mode. When a client communicates with the DHCPv4 server, the server assigns or leases an IPv4 address to that client. The client connects to the network with that lease IPv4 address until the lease expires. The client must contact the DHCP server periodically to extend the lease. So if the lease is about to expire, the client can contact the DHCP server in order to extend that lease or obtain a new IP address. This lease mechanism ensures that the clients that move or power off do not keep the addresses that they no longer need. When a lease expires, the DHCP server returns the address to the pool where it can be reallocated as necessary. So let's look at how DHCP server will be handing out that IP address to the client and how the client can request it and receive it. So when a client boots or otherwise want to join a network, or in other words, if you have a laptop that's already boot up, but now you're connecting to that Wi-Fi network with the DHCP server, it begins 4-step process to obtain a lease. It sends a message called DHCP discover, looking for a DHCP server. Then the DHCP server, whichever the DHCP server that first respond back to that client, gonna have a DHCP offer message. And when the offer message is received by the client gonna send a DHCP request message. And then finally, the DHCP server gonna send a acknowledgement message back to the client. So what really important here is you need to learn and understand this process of obtaining that lease. So the DHCP discover, DHCP offer, DHCP request, and DHCP acknowledgement, in that order is how a client would obtain an IP address from a DHCP server. One of the tricks that I use to remember this process, which is very famous, is DORA. So DORA, discover, offer, request, acknowledge. That will come up as DORA. So if you want to remember this discover, offer, and request and acknowledge. So this is discover. So discover, offer, request, and acknowledge. So that will spell out as DORA, DORA. And that an easy way to remember the steps that need to take a lease for DHCP. So if a client connects, it goes through the DORA process. That's how I remember. So it will give you those steps in that order. This is important for your CCNA as well as CCNP exams and quizzes. So make sure you know these steps in that particular order. So remember DORA, discover, offer, request, acknowledge. That's the process every single time a brand new client connect to your network, or the client boots up to the network and requests that DHCP. So having said that, now we will look at how you can renew a DHCP IP address received by the client. So prior to lease expiration, the client begins a 2-step process to renew the lease with the DHCP version 4 server, and it is shown on this figure on the right hand side. We have the DHCP request unicast message, and then the DHCP acknowledgement unicast message sent back from the DHCP server. So the DHCP request message is happening before the lease expires, it is sent by the client directly to the DHCP server that originally offered the IPv4 address. If a DHCP pack is not received within a specific amount of time, the client broadcasts another DHCP request so that one of the other DHCP version 4 servers can extend the lease. The DHCP acknowledge message, which is sent from the DHCP server, will send a message as a response to the DHCP request message and verify the lease information through that message to the client that requested it. Please note, these messages, mostly the DHCP offer and DHCP acknowledgement, can be sent as unicast or broadcast as per IETF standard RFC 2131. You don't need to know this specific standard per se for your exams and labs, but you should know that this can the DHCP offer and DHCP acknowledgement can be either unicast or broadcast. This reminds me something else I forgot to mention on the previous slide. If you go back here, you can see the initial message your client gonna send out to get a DHCP IP address is to find the DHCP server, because that's the initial action that it needs to perform, right? We don't know where the DHCP server is located when you first connect it. So the client doesn't know where it is. So it's always going to be a broadcast message. The very first one, the DHCP discover, going to be a broadcast message. But however, the response now, it's going to be from the DHCP server, which is the DHCP offer, going to be a unicast message, because the DHCP server now knows where the client is, because the client has sent that broadcast message and the server is responding to that broadcast message as a result. So it knows where it needs to go. So it's going to be a unicast message. And when the unicast message is received by the client's still going to send a broadcast message saying, hey, can I accept the IPv4 address offer? And then that broadcast message is get responded with the acknowledgement message, which is going to be a unicast message. So you should actually know these, whether they are unicast or broadcast, for your exams and quizzes as well. That's something I forgot to mention in this particular slide, but remember that that's an important concept as well. So the next one we're going to cover is how we can configure a Cisco iOS DHCPv4 server. Now you have a basic understanding of how DHCPv4 works and how it can make your job a bit easier. Because having this DHCP version 4 server, you don't need to go to your each end client and manually assign IP addresses and other information such as the DNS server addresses, etc. A Cisco router running Cisco iOS software can be configured to act as a DHCPv4 server. The Cisco iOS DHCPv4 server assigns and manages IPv4 addresses from a specified address pools within the router to DHCPv4 clients. And we will go through how we can do it on these slides in next few slides. However, as I mentioned multiple times in my previous lectures, all of these configuration I will do on live demo labs and post to my YouTube channel as separate videos, so you have a better hands-on experience and idea about how these are configured. So for now, just remember this topology, because that's what we will be using for the next few slides. And we're going to be implementing a DHCP version 4 server right here with two different IP address pools, one with the subnet 10.0 and the other one with the 11.0. There's going to be two different networks, and that will be assigning to switch 1 connected devices and switch 2 connected devices. So use the following step to configure the Cisco iOS DHCPv4 server for that topology that we are gonna be looking at. So for any topology, we can use the same steps. It's the same configurations. This is an example we are using given to us by Cisco, because the slide set is provided by Cisco. But it could be any type of topology where you are trying to implement a simple DHCP server, right? So the very first step is you need to exclude any IPv4 addresses that you will be using for static IP addresses. So exclude IPv4 addresses is for the use by statics, IP addresses that you will be needing for servers, etc., etc. So a single address or a range of addresses can be excluded by specifying a low address and a high address of range. Excluded addresses should be those addresses that are assigned to routers, servers, printers, and other devices, as I mentioned, that will be manually configured. This is very important, especially for servers, because you don't want that server IP address keep changing every time, because that's going to create an administrative nightmare if you have servers with DHCP. So we're going to be assigning those static IP addresses of servers, and also devices like network printers and routers. You can also enter the command multiple times. So the command is IP DHCP exclude address low address, and then you can give the high address next. So you're going to have the IP DHCP exclude address, and then you have the low address and the high address. Again, I will go through them on a live demo as well as some additional slides later. This is just remember those, that's the command we're going to use. In step 2, we're going to define the DHCP version for pool name, v4 pool name. And in order to do that, what we use is the IP DHCP pool, and then we're going to give the pool name. So IP DHCP pool is the command, and then you're going to give whatever the name you would like to give. And this command creates a pool with the specified name and puts the router in DHCPv4 configuration mode, which is identified by the prompt router DHCP-config. So when you enter IP DHCP pool and then you enter the pool name, you go inside it creates that pool name, it creates that pool, and then you go inside the configuration mode or configuration section of that pool. And you can see that by looking at that, this part, DHCP-config in these brackets, now you are inside a configuration of that particular pool. The next step, the final step, is the configuration of the DHCPv4 pool. The address pool and the default gateway router must be configured, and we use the network statement to define the range of the available addresses, and we're going to use the default-router command to define the default gateway router. These commands and other optional commands are shown in here in this table. And as you go through these courses from Cisco, you will get to know all of these commands like back of your hand. Like you'll remember them even in your sleep, because you will be repeating these commands for your labs over and over and over. And you're going to be really used to these commands. And one of the nice things about Cisco iOS commands, they are very kind of meaningful in English language. Like for example, if you want to define the address pool, you go network and you basically put the network number and the prefix marks and etc. And if you want to define the default gateway, your default router, in this case we're gonna put default-router, and then you're gonna enter the IP address. It's pretty self-explanatory. Like if you're using it's basic English in most cases. That's one thing I found very useful with Cisco commands. Like for example, you want to name a DNS server, it's DNS-server. So these are different ISO commands that you will be using to configure that DHCPv4 pool, and most of them are pretty self-explanatory because of the way that the iOS commands are built. One thing I want to mention here is that the NetBIOS server information, you're probably not going to configure those in this class, but you will be in the advanced classes with the simulation and emulation programs such as the EventG, for example. But for now, we are not going to be worried about NetBIOS in this class. So here's a lab demonstration example of a configuration. Remember that network diagram I said we will be using? Well, it's the same network diagram here. So we have a router with two switches connected on G00 and G001, and we have switch 1 and switch 2, but we have two different pools associated with it. So in here we have an excluded range of IP addresses. It's right here. We are excluding 192.168.10.1 to 192.168.10.9. So that's a range of IP addresses that are going to be excluded. And we have another excluded IP address here, 192.168.10.254. Maybe it's used for management, maybe it's for something else, but it has that. And then we have the IP DHCP pool name, and we name it LAN-pool-1 because we will be configuring that pool, basically this side of the network. And we're going to give the network 192.168.10.0 to, and with the subnet mask of 255.255.255.0, which is basically saying this is the network we'll be using. Then we're going to give the default router, which is 192.168.10.1. That will be this port because that is 10.1. So 192.168.10.1 is the G000. And the DNS server, we're going to pick the DNS server from here, which is going to be 192.168.11.5 because that's what the DNS server in this diagram. And we're just going to give a domain name. It could be any domain name or your company name, .com, whatever. And you can exit out of this. And remember, when you are doing this on labs, make sure to do the copy running start config commands, startup config commands. Otherwise, when you shut down your lab and reboot or something like that, you reboot one of those things, your configuration may be gone. So make sure you do that. And this example also shows that you can have multiple DHCP pools. This example also shows that you can configure excluded IP addresses, as well as you can give a completely different DNS server. You can give a DNS server that is completely different from the DHCP pools and the network that you are creating. So here we have 11.5, but the DHCP pool is on 10. Range, but that's okay because it's a separate configuration, right? So that's what is shown here. So this is what you would be doing on a Cisco router if you were to create this pool. So let's look at how you can verify the DHCPv4. You can use the commands shown here in this table to verify the Cisco IOS DHCPv4 server is operational. So once you have created that pool, you can make sure that the pool is operational and working. So they include show running -config, and then you can pipe section DHCP, show IP DHCP binding, show IP DHCP server statistics. One of the things I use once, so I have access to a router that has been pre-configured with the DHCP pools by another system technician or administrator, is to run show IP DHCP server statistics, because that will display the information regarding the DHCP version 4 messages that have been sent and received, and also give you an idea about whether the DHCP server is actually working. So all of these things I will go through in a lab demo, so you'll have a better idea about how to use them. But for now, just know that these commands exist because those are important for this course. So in this slide, it shows some of those commands. Again, it's not live demo right now, it's just screenshots, but again I will go through the live demos later. So here we are verifying the DHCPv4 configuration, and in this example we are running the show running config with pipe selection DHCP command, and that shows the information related to that DHCP version 4. So if you run show running config and hit enter here without the piping, what's going to happen is you're going to have all the configurations you have done for that RAR1 router display on your terminal. Nothing wrong with that. I mean, I do that all the time. It gives you a lot of information, everything configured. But if you just want to look at the DHCP, you can just pipe, select the selection DHCP, and that will give you just the DHCP data here. So this is a neat way to get less data when you don't need a lot of data. So it shows the excluded IP addresses, it shows the pool name, it shows the network information, default router, DNS server, and the domain name. So you can verify the DHCP version 4 bindings. Bindings are basically means like, what are the IP addresses that we, we're going to be use, like what are the binding information, like the type, like associated information. So as shown in this example, the operation of DHCPv4 can be verified using the show IP DHCP binding command. This command displays a list of all IPv4 to MAC address bindings that have been provided by the DHCPv4 service. So it shows here, for example, we have an IP address of 192.168.10.10 is leased out to this client because this is the client's hardware address, which is the MAC address, and it shows the expiration, lease expiration information and what type of DHCP lease. So the bindings gives you that statistics that you can check on a DHCP pool. Another way you can look at statistics for leasing is the DHCP version 4 statistics that can be displayed by running the show IP DHCP server statistics command, and that is used to verify that the messages are being received or sent by the router. And this command displays the count information regarding the number of DHCP version 4 messages that have been sent and received. I don't usually use this command a lot compared to the previous commands that we went through, but it is still a useful information for troubleshooting. For example, when you have a DHCP server acting out, you can check this data to figure that out. But I use this command, the previous command, this one, a lot, because reason for that is if a client is not receiving a DHCP or a DHCP is not getting renewed, that's that some of those information may be able to pinpoint from the show the IP DHCP binding command. But this command shows the overall picture of your DHCP server in terms of receive and send packets. That could be a good indicator on whether the DHCP server is actually responding to those messages. And there's another one that you can use on computers to verify that your DHCP is working on the client side, and that would be the ipconfig command, especially on the Windows machines in this case. The ipconfig command have a couple of options. So if you just enter ipconfig, it's just going to give you the IP address and DNS address as well as the default gateway information, and nothing much on the ipconfig command. But however, if you use the ipconfig/all command, which is shown on the right hand side here, ipconfig/all command, when you issue that to a Windows PC, it will display the TCP IP parameters with lots of information that you need. In here, because PC1 is connected to the network segment 192.168.10.0/24, it automatically receives a DNS suffix, IPv4 address, subnet mask, default gateway, DNS server address from that pool. No DHCP specific router interface configuration is required. If a PC is connected to a network segment that has a DHCPv4 pool available, the PC can automatically obtain the IPv4 address from appropriate pool. In this case, that's what happened. We know that because it's when you go DHCP/all, we see that pool information being generated right here, and that is the same information we set up before in that router. It has the default gateway and the DNS server that we pick. And we know it is an automatic DORA process happen here as well, because we have the lease obtain information and we also have the lease expire information. So we know this is a DHCP that been obtained by this computer. Disable the Cisco iOS DHCPv4 server. So there are situations you don't need the DHCPv4 server running on your Cisco device. So how you can do it is to run no service DHCP command right here, no service DHCP command in the global configuration mode. You can also use the service DHCP in the global configuration command to re-enable the DHCP version 4 process. And it is shown here on the right hand side. They turn off the DHCP server by running no service DHCP, and they turn back on by running the service DHCP. Enabling the service has no effect if the parameters are not configured. That's a key information that you should also remember. So if you have the service enabled but you have no parameters set to it, like such as the DHCP pool, the DHCP pool name, excluding IP address, etc., etc., it's not gonna assign any hand over that information to any clients that are requesting it. So you just enabling it have no effect on the parameters if it is not configured. Please note, clearing the DHCP bindings or stopping and restarting the DHCP service may result in duplicate IP addresses being temporarily assigned to the network. So in other words, if you shut this service down by issuing the no service DHCP and you put it back online by service DHCP, and if there are clients that already receive the DHCP and working on the network, it may temporarily for a moment have a duplicate IP addresses that are being handed out to the next client that requesting the DHCP, but it will get resolved through the, remember, the DORA process, and the DHCP server will take care of that in a few seconds to minutes after it boots back up. DHCPv4 relay. In a complex hierarchical network, enterprise servers are usually located centrally. These servers may provide DHCP, DNS, TFTP, and FTP services for the network. Network clients are not typically on the same subnet as those servers. So in order to locate the servers and receive services, clients often use the broadcast messages. In this figure, the PC1 is attempting to acquire an IPv4 address from a DHCPv4 server using a broadcast message. So you have PC1 and they're sending a broadcast message looking for an IPv4 address. Because the DHCPv4 server is located on a different network, the PC1 cannot receive the IP address from DHCP. So the DORA gonna fail. R1 must be configured to relay DHCPv4 messages to the DHCPv4 server because the DHCPv4 server is located at 192.168.11.6, but this network here that the PC is connecting to is 192.168.10.0. So the DHCP server is on the network of 192.168.11.0 because its server IP address is 192.168.11.6. So basically what happening here is that this PC is requesting an IP address from a DHCP server which has a pool outside of the 192.168.10.0 network which the PC is now connected to. So there is no way the PC's those DORA messages can reach the request messages can reach this server unless this router is configured with a DHCPv4 relay. So we need to make sure that the R1 must be configured with the DHCPv4 relay, so that it will the PC can reach this DHCP server on a different network and still obtain an IP address. Here's a question for you. This is a good question that might show up on your CCNA and CCNP exams, most likely the CCNA exam. Can this DHCPv4 server issue an IP address in the pool range of 192.168.10.0 even though the DHCP server has an IP address in 11.0 range? The answer is yes, you can. So you can actually create the DHCP server here for both 192.168.10.0 and 192.168.11.0 networks. Both networks DHCP servers can be located in this server with the IP address 192.168.11.6 because you have the ability to create those two pools on the same server and still hand out IP addresses to the both networks. You just have to make sure that the router that is dividing this broadcast domain is configured with the relay DHCPv4, and you can have both pools on the same server even though the server is located on one of the networks, not on both. It's perfectly fine. You can do that, and that is mostly how DHCP servers are done in corporate and office environments anyway. So you need to configure R1 with the IP help address. So this is where the relay configuration gonna be implemented on the router. So the command IP helper -address, and then you're gonna enter the IP address interface in the interface configuration command. So this will cause the R1 to relay DHCPv4 broadcast to the DHCPv4 server. As shown in the example, the interface on R1 receiving the broadcast from PC1 is configured to relay DHCPv4 address to the DHCPv4 server at 192.168.11.6. We know this because we put IP helper -address, and we gave the IP address of that DHCP server, which is on the previous slide. We have 192.168.11.6. And if you go to the next slide, you see that 192.168.11.6 is that help address, which is the address of that DHCP server. So basically, that it means this router now have the relay information for the DHCP server. So when R1 has been configured as a DHCPv4 relay agent, it accepts the broadcast request from the IPv4 service and then forward those requests as a unicast to the IPv4 address of 192.168.11.6, which is the DHCP server. The network administrator can use the show IP interface command to verify the configuration. So on the R1 router, you can run the show IP interface, and then you can G000, and then that will display the relay information. I also need to highlight one more thing here. If you look at our network diagram right here, the G000 is the interface that is facing the 192.168.10.0. So remember that. That is the interface which the PC1 default gateway, that's the interface for this network. So the IP helper address, which is the 192.168.11.6 address that we are entering for the relay of the DHCPv4, will be given on that interface. So if you go back here, we are actually configuring G000. So it's not configuring this side G001, because there is, the message not going to be received on this end. The message going to be received on this default gateway. So remember that. So with the PC is reaching the default gateway interface of G000, and that G000 interface is the one that we're going to create that IP help address, which is 192.168.11.6, which is the IP address of this DHCPv4 server, which is on this side of the network with that network on the assigned. So that's a key important piece of information that you should understand from this. So there are other broadcast relayed messages. So DHCPv4 is not the only service that the router can be configured to relay. By default, the IP helper -address command forwards the following 8 UDP services. So when you do IP space helper -address command, we did on the previous slide, this command, and you enter that IP address, it will by default relay all of these messages, not just the DHCP messages. So it's going to be port 37 time messages, port 49, port 53, 67. Those are the DHCP commands, DHCP packets, DHCP server and client, 67 and 68. At 69 going to be TFTP, 137 NetBIOS, and 138 for NetBIOS as well. So for your exams, for CCNA exams, you don't really need to know the exact port numbers here and associated items that been relayed out as a result of entering IP helper dash address, but you should know that is more than one message relay information has been sent. So more than one service broadcasts are relayed when you use the IP help address. However, if you are taking this class through a academic institution, your instructor may require you to remember these items associated with the IP helper address. So speak to your instructor whether you need to know this exactly, what port associated with what service, and how it is part of the IP helper address command. So when you enter IP address, these things get relayed. Speak to your instructor about that, because I've seen some exams may ask you these questions. I've seen some exams did ask that question, but the exams I have taken with Cisco NetAcad, for my certification, I never got a question where they ask you for a IP helper address, extensive information about these port numbers and the UDP services. So that's something you need to check with your instructor. If you have access to the packet tracer file called configure DHCPv4, please go ahead and download it from your Cisco NetAcad or through your academic institution and do them. If you do not have access to it, I will post a copy of this file to my website sanuja.com, so you can get some hands-on experience with lab material. I would recommend that you do these labs as you go through this lecture, so that you have a comprehensive understanding of the topics that we have covered. Configure a DHCPv4 client. Cisco router as a DHCPv4 client. So there are scenarios where you might have access to a DHCP server through your ISP, the internet service provider. In these instances, you can configure a Cisco IOS router as a DHCPv4 client. Sometimes Cisco routers in a small office or home office, SOHO, and branch sites have to be configured as DHCPv4 clients in a similar manner to client computers. The method used depends on your ISP. However, in its simplest configuration, the Ethernet interface is used to connect to a cable or DSL modem. So most home users, for example, will have an ISP providing a IP address, and however the home users will have a router that will have an automatic DHCP setup. But in some environments, such as small office or home office environment, you may get a DHCP directly from ISP, and that's where we're going to use the IP address DHCP interface command in the configuration mode. So to configure basically an Ethernet interface as a DHCP client on a Cisco router, what we do is to use IP address DHCP interface right here, IP address DHCP interface command in the configuration mode. So in this figure, for example, on the bottom, we assume that the ISP, internet service provider, has been configured to provide select customers with IP addresses from 209.165.201.0/27 network range, and it will be using the G001 interface to obtain an IP address from that ISP. And how we're going to do it is by running the IP address DHCP command. So we're going to go into that G001 and we're going to run the IP address DHCP command, and that will configure your Cisco router to obtain an IP address from ISP's DHCP. So next slide, I will show you, how that works with an example. So here's the configuration example. So to configure an Ethernet interface as a DHCP client, so we use the IP address DHCP interface configuration mode command as shown in this example, as I mentioned in the previous slide. So the ISP is configured to provide that DHCP IPv4 addressing, and so we have the interface G001 because that's the interface we're going to configure now, and we're going to enter the IP address DHCP. And we're gonna turn the interface on by issuing the no shutdown command. And right here, the Cisco iOS, it is providing a useful message saying that, hey, it is up and it is ready to go, and it's been it's gonna be set as exactly what we have defined here. It's gonna be a DHCP client. Next, we can run the show IP interface G001 command. So using that command, we can check what happened to this particular router. In this case, it shows the router did obtain an automatic IP address or DHCP IP address, and this is the IP address it has received, and it has the broadcast address, and it says here address determined by DHCP. Hence we know that this is actually working. So that's how you create configure your router to be a DHCP client, and this is how you actually check whether that the system is working as expected. Home router as a DHCPv4 client. Home routers are typically ready to receive IPv4 addressing information automatically from ISP. This is so that the customers can easily set up a router and connect to the internet. For example, the figure shows the default WAN setup page for a packet tracer wireless router. Notice that the internet connection type is set to automatic configuration /DHCP. So right here, automatic configuration -DHCP. This selection is used when the router is connected to a DSL or cable modem and act as a DHCPv4 client, requesting an IP address from the ISP. Various manufacturers of home routers will have similar setup, but the user interface GUI would be different from router to router because of depending on the router model. Even within Cisco router model could have an impact on how the firmware looks and feel, but the configuration is very similar to each other. That would bring us to the end of this lecture, and I'm going to quickly go over what you have learned. And we know there are a few packet tracer files always with these lectures associated with everything that we have covered. And for this lecture, it is called the implement DHCPv4. If you have access to this file, please go ahead and do them. If you do not, I will find a copy and post to my sanuja.com website so you can download and do them. There's another file called implement DHCPv4 lab, and again, if I find that copy, I will post to sanuja.com website so you can download and do them if you do not have access to these files. So let's look at a summary of what we have learned in next few slides. So we learned the DHCPv4 server dynamically assigns or leases an IPv4 address to a client from a pool of addresses for a limited period of time chosen by the server or until the client no longer needs the address. The DHCPv4 lease process begins with the client sending messages requesting the services of a DHCP server. If there is a DHCPv4 server that receives the message, it will respond with an IPv4 address and possible other network configuration information such as the DNS information, domain name, etc., etc. The client must contact the DHCP server periodically to extend the lease. This lease mechanism ensures that the client that move or power off do not keep the addresses that they are no longer needed. So if the DHCP server doesn't hear back from the client, it can reassign that IP address, assuming that the client no longer need it. When the client boots or otherwise wants to join a network, such as connecting to a Wi-Fi network or first time connecting your already boot up computer to the network, it begins a 4-step process to obtain the lease. Those are DHCP discover, DHCP offer, DHCP request, and finally DHCP acknowledge. Please, if you don't remember this particular step in order, remember the DORA. I mentioned DORA. So DORA stands for discover, offer, request, acknowledge. DORA. And you need to remember this for your exams and quizzes for sure for both CCNA and CCNP. So DORA is an easy way to remember that. And prior to lease expiration, the client begins a 2-step process to renew the lease with the IPv4 server, and that request process is the request and the acknowledgement. So those are the 2-step process for renewing a lease. A Cisco router running Cisco iOS software can be configured to act as a DHCPv4 server. Use the following steps to configure Cisco or iOS DHCPv4 server. We basically exclude any IPv4 addresses we will be using for static IPs, for servers and printers and etc. Define an IPv4 pool name and configure the IPv4 pool. You can verify the configuration using the show running config pipe section DHCP. If you don't do the pipe, it will show everything on your router, and that will also still include the DHCP information as well. Show IP DHCP binding command. Command, and the show IP DHCP server statistics command will also display some useful information. The DHCPv4 service is enabled by default on all Cisco iOS devices. However, you can disable the service by running no service DHCP in global configuration command. We also learn that if you actually run the DHCP server on the iOS, enable it, but you don't have any configurations done, it's not going to do anything because it doesn't know what IP pools to be used, etc. etc. So make sure you, just by running, turning on the server doesn't mean it's actually handing out the IP addresses unless you actually configure it in Cisco iOS, right? Remember that. That's a key information that's not on this slide, but it was on the previous slides that we just went over. Network clients are not typically on the same subnet as enterprise servers providing DHCP, DNS, TFTP, and FTP services for the network. In order to locate the servers and receive services, clients often use broadcast messages. However, the router must be configured with the relay DHCPv4 messages to the DHCPv4 server. So router is not configured with a proper information. The DHCPv4 messages will not be relayed across different network. So the network administrator can configure the router with the IP helper address. So you're going to go IP helper dash address, and then you can enter the IP address of that, wherever the server is located in the interface configuration command, and use the show IP interface command to verify the configuration. Again, another key piece of information I went over, the IP helper dash address command is entered on the interface where it is facing the client which is trying to obtain the DHCP. So it is actually entered on the router where the default gateway of the the devices that are trying to seek out that DHCP server on the other network. So it's going to be on that side. So remember that. You also learn by default the IP help address command forwards the following 8 UDP services, and they are listed here. As I mentioned before, you should speak to your instructor if they are going to include specific questions related to these specific port numbers and associated services or not, because I haven't seen on my exam, but you might get it on your CCNA exams. To configure an Ethernet interface as a DHCP client, we use the IP address DHCP interface configuration mode command. We learned about that in the previous slide as well. We also learn on our final slide that home routers are typically already set to receive IPv4 addressing information automatically from the ISP. The internet connection type is set to automatic configuration .DHCP, so that home routers will automatically obtain that IP address from your ISP. This section is used when the router is connected to a DSL or cable modem and act as a DHCPv4 client requesting an IP address from the ISP. And that is the end of this lecture. If you like these type of lectures, please thumbs up this video and subscribe to my channel. If you have any questions related to any of the topics that we have covered, feel free to reach out to me. Please make sure to go over these lecture notes before you take your module quiz or lecture exams. Until next time, good luck with your exams and have a nice day.